Peel and root, healing the future from the root.
Amid global industrial shifts, the nickel wire industry is rising from industrial MSG to a strategic material. As a core input for new energy batteries, aircraft engines, and semiconductor packaging, it has become a focus of national industrial competition. The industry's evolution follows three interlinked dimensions: structural changes in supply-demand patterns, diversification of technological innovation, and the reconfiguration of the global value chain. These dimensions are mutually reinforcing and together define the industry's future path. The global nickel resource pattern is undergoing significant shifts, marked by a clear, dual-track structure. Laterite nickel ores, which account for over 60% of global reserves, are concentrated in equatorial countries like Indonesia, Australia, and the Philippines. In contrast, high-grade nickel sulfide ores are mainly found in Russia and Canada. This uneven distribution has naturally split the industrial chain and led to divergent development paths. Recently, resource-rich countries like Indonesia have begun transitioning from raw material exporters to industrial hubs by enforcing export restrictions, driving local processing and reshaping the competitive dynamics of the global nickel industry. China faces a pronounced resource dilemma in the nickel sector. Its laterite nickel ore reserves account for only 9.6% of global totals, with most deposits being low-grade and costly to mine. Over 90% are low-grade, with mining costs more than 40% higher than in Indonesia. This small quantity, poor quality endowment forces China to import over 60% of its laterite nickel ore annually to sustain its stainless steel industry. However, this sharp resource demand tension has also become a catalyst, driving Chinese enterprises to accelerate global deployment and invest in technological innovation. In high-end nickel materials, the United States, Germany, and Japan have established strong technical barriers. The U.S. monopolizes high-purity nickel production via the carbonylation process, achieving 99.99% purity and securing a premium of over 50% in aerospace. Germany's Inconel high-temperature alloys remain irreplaceable in aircraft engines. Japan holds a near monopoly in ultrafine nickel wire, commanding 60% of the global market. These technological advantages deliver high profits and strategic control over key downstream industries. Faced with technical barriers, Chinese companies have pursued differentiated breakthroughs. China now holds over 40% of global nickel sulfate capacity, and its nickel-iron smelting technology has reached internationally advanced levels. However, major gaps remain in high-end areas like high-purity nickel powder and ultrafine nickel wire, with over 80% of aviation-grade nickel materials still imported. This strong in the middle, weak at both ends pattern remains a core challenge for China's nickel industry upgrade. The transformation driven by digital technology and the new energy sector has triggered a nickel demand singularity. The widespread adoption of new energy vehicles has increased the nickel content in ternary lithium batteries by over 30%, fueling steady annual growth in nickel wire demand. The rapid rollout of 5G base stations has created new demand for precision nickel wire. Notably, the rise of the hydrogen energy storage industry may lead to a breakthrough in nickel wire applications, expanding from industrial to consumer use and shifting the industry from product-based to ecosystem-based competition. The essence of competition in the nickel wire industry lies in a three-dimensional game of material precision times industry synergy times resource control. In this global strategic contest, maintaining focus and overcoming resource and technical constraints is key to gaining an edge in industrial transformation. For nickel wire consulting services, please contact us.